regarding reactions due to the benzene ring. In another way, we call it as the electrophilic substitution reactions. Electrophilic substitution reactions. Substitution reactions of aromatic amines. Okay. Aromatic amines is, this is another way we call it as the reactions due to benzene rings. Aromatic amine is nothing but what is this? Aniline. Aniline is nothing but aromatic amine. Okay. In this aniline, see the nitrogen, that is benzene ring contain aniline, that NH2 group. I already told you there will be, like in ammonia, there will be a lone pair of electron on this here, nitrogen. Because of this reason, what happens? These a lone pair of electron are present on the nitrogen will be donated to the benzene ring. This will be donated to the benzene ring. Therefore, the ring will be more activated. Means the NH2 group is said to be the activating group. It is said to be the activating group. That's why whenever we treat with the bromine, in presence of what we call it as the, that is a what you can say, that is bromine water. Bromine water means this is nothing but bromine dissolved in water. Bromine dissolved in water is said to be the bromine water. Okay. When it is treated with the bromine water, because the aniline or NH2 group on the benzene is a activating group, therefore what happens, the activating group always orient the what I mean to say, the incoming group to the ortho and para positions. Ring activating groups always direct the incoming group at either ortho position or para position. But because this is aniline is more highly activating group, therefore what happens, the three positions, that is going to be the here ortho position, this is para position, again this is ortho position. And here what happens, the bromine is substituted is here. The bromine is substituted like this. That can anybody tell me what may be the name of this compound? What may be the name of this compound? This is aniline.
Yes,
then how to write this name of this compound? This is going to be the first carbon, second carbon, third, fourth, fifth, and sixth. Therefore, what to write? 2, 4, 6. How many times? 3 times. Therefore, try. What is the substitution present? That substitution is bromine. Therefore, we call it as a tribromo aniline. Aniline. This is a compound called as tribromo aniline. That means this reaction is not controlled because it is highly activating group. Whenever it is treated with the bromine water or even in presence of KBr also, potassium bromide. That is potassium bromide. This will be reacts and the 3 positions will be occupied by the group. That's why it is uncontrolled reaction and it is not possible to control or substitute the bromine at a single position. That's why we'll get a white precipitation. This is a white PPT. I think you will going to do the practical also in the laboratory. This is 2,4,6 tribromo aniline. Then how to control this reaction? How to control this reaction? This reaction can be controlled. This aniline, this reaction can be controlled by deactivating this NH2 group. I told you this is going to be an activating group. I told you, isn't it? The NH2 group is an activating group. Therefore, when it is treated with the bromine, the 3 positions will be occupied. Then how to control this reaction? This can be controlled. First of all, we have to deactivate this group. Then how to deactivate this group? First of all, it is treated with what I mean to say sodium. That is, it is treated with any acetic acid. It is treated with any acetic acid or acetylating reagents. They are said to be the acetyl reagent is said to be the acetic anhydride CH3. Okay, I will take this. See the CH3CO, and here you can keep the bracket here and here. You have to tell me what is the name of this compound. This is the compound. Can anybody tell me what may be the compound? Okay, here it is going to be the oxygen. I have to write oxygen. Okay. Now what maybe it is? Generally it is represented with what is called as AC2O. Can anybody tell me what is the name? It is going to be the acetic anhydride. It is called as acetic anhydride. Whenever it is treated with this acetic anhydride, and here we'll get an acetonylide compound. Here this is going to be the formed, and that is here what happens, that is going to be the, instead of the one hydrogen, you will get the compound is here, that is COCH3. COCH3 is formed. This is called N-acetylation. After this acetylation, what happens? The ring here, it is highly reactive. This is highly activating group, whereas here this acetyl group is highly deactivating. Because of this reason, when this is now treated with the bromine water, when here already we wrote here, this is going to be the bromine water. When it is treated with the same reagent, when it is treated with the same reagent is here, with the same reagent, what happens here? Either the position will be taken by at ortho position or para position. See, okay, now here you will get the bromine is introduced either at ortho position, and another one going to be the at a para position also. Here these two compounds are formed. Another is going to be, you will get at a para position. Here you will get the bromine, that is orthobromoacetonylide, its name, and here it is said to be the para-bromoacetonylide. This is going to be the para-bromoacetonylide is formed. This is orthobromoacetonylide, this is para-bromoacetonylide, both are formed. Then how to recover this again to aniline? That means first the highly activating NH2 group is deactivated by treating with acetic anhydride, so that it is deactivating group. Now when it is treated with this bromine water, then what we'll get here? The bromine will be introduced either at ortho position, or that is mono substituted will be formed. Now this is this mixture when it is hydrolyzed. What do you understand by the hydrolysis? Reaction with water. When it is hydrolyzed, either in presence, that is in presence of any base, in presence of any base like sodium hydroxide, simply what we will get here, you will get this what is called as the para-bromoaniline or orthobromoaniline is formed. See here these compounds. Okay, the both compounds will be formed here. Either it is going to be the para-bromoaniline or orthobromoaniline will be formed. I will write here now. See, this is going to be the two compounds will be formed. The two compounds will be formed. The first compound is here at ortho position. Therefore, you will get here orthobromoaniline. Another one is the para-bromoaniline is formed. Let us write the structures. See, this is going to be orthobromoaniline. This is going to be the para-bromoaniline. That is what is what is here. What you have understood. The NH2 group is highly activating group. Because of this reason, direct bromination of aniline will give 2,4,6 tribromoaniline. But the mono substituted aniline can be prepared by deactivating this NH2 group, treating with the acetic anhydride, and so that you'll get acetonylide. This compound is called as acetonylide. And this acetonylide, when treated with the brominating reagent, that is bromine water, you will get either orthobromoacetonide or parabromoacetonide. When this mixture is hydrolyzed, again this acetyl group is removed, then you will get ortho or parabromoaniline. This is going to be the orthobromoaniline. This is orthobromoaniline. Aniline. This is what is this compound? What is this compound? This is going to be the parabromoaniline. Okay. This is going to be the how to brominate. This is going to be the bromination of aniline. Now let us go for the another one. Let us take the nitration. Are you there? Okay. See, let us go for the nitration reaction. What is nitration? Nitration is nothing but what? Nitro group, introduction of nitro group. Nitration of aniline. See, what is the nature of the aniline? Can anybody tell me? Is it basic or acidic nature? Aniline, what is the nature of the aniline?
Basic.
Basic nature. You remember, all amines are basic in nature. Okay. There will be a lone pair of electron, and that's why what happens? What happens here? When it is treated with any acid, first of all, it forms a salt. It forms a salt, and actually, the nitration of benzene ring requires a strong acidic medium, that is nitration mixture. The nitration mixture is nothing but mixture of concentrated nitric acid and sulfuric acid. That's why whenever it is treated with nitration mixture, because this needs, what I meant to say, this needs a strong acidic medium. That's why the nitration of benzene ring or electrophilic in this electrophilic substitution reaction, we use the compounds is, one is the concentrated nitric acid, that is another is the concentrated sulfuric acid. This mixture is said to be the nitration mixture. And whenever we use this mixture, then only we carry out the nitration. But because it is a basic in nature, first of all, it forms a salt. How does it form a salt? Here, because here it takes a proton. It takes a proton and form anilinium ion. Means here one more, because here, see here, you will get one more hydrogen, and instead of this lone pair of electron, there will be a positive charge is formed. Like this, there will be a positive charge is formed on the nitrogen. This is what is called as anilinium ion. This is called anilinium ion. And because of the formation of this anilinium ion, and this I told you just now, it is highly activating group. But after this lone pair of electron is donated to the proton of this acid, then it becomes anilinium ion. There is no lone pair of electron available that donates the benzene. Therefore, now this is a ring deactivating group. Now what happens? It will take here this nitric acid, and in the presence of nitric acid and concentrated sulfuric acid, in presence of concentrated nitric acid and sulfuric acid, all ring deactivating group, in the ring deactivating group, the NO2 group enters, or the electrophile enters into meta position. You remember this very important point. In ring activating group, the incoming group goes to the ortho or para position. Whenever ring deactivating group is present, in such cases, the incoming electrophile enters to or goes to the meta position. And this is what is called meta-nitroanilinium. Then how to prepare this, what I meant to say, ortho-nitroaniline or para-nitroaniline? similar to the previous case. What is that previous? First, we have to make this into a ring deactivating group, that is reacting with an acetic anhydride. Reaction with acetic anhydride. For I think you understood now what is that? Acetic anhydride. Simply we write like this. Acetic anhydride. General గా మనము టెక్స్ట్ బుక్ లో గానీ ఎక్కడైనా ఇలా రాస్తాం AC2 అంటే acetic anhydride. When it is treated with this acetic anhydride, what happens? The aniline become ring that is NH2 group become ring deactivating. What is that? Acetonylide is formed. Here, this is going to be the acetonylide is formed COCH3. This is I told you just now. COCH3 is formed, and this is called ring deactivating group. Now, in this case, what happened now? You can that means this is what I mean to say. This is a highly activating group, but the reactivity of the acetonylide is less than this aniline. That's why whenever it is treated with now HNO3 and H2SO4, that is this mixture, with this mixture, and what happens here? Now you will get the compound is either para orthonitroacetonylide or para nitroacetonylide is formed. This will be, and here this is going to be the one compound, and you will get another compound also, that is going to be the para nitroacetonylide also formed. See here like this. One is going to be at ortho position, another is going to be at a para position. Now here we have to write here NO2. Now here also NO2. In this way, we will get orthonitroacetonylide or para-nitroacetonylide. Which on hydrolysis? Just now I told you this also. Which on hydrolysis? Hydrolysis means what? Hydrolysis means what? Reaction with water in presence of basic or basic medium. See what happens. You will get this compound, that is para-nitroacetonylide or orthonitroacetone. This is one compound, and you will get one more compound, and here at ortho position you will get at ortho position and at a para position. That is what to write here. NO2. Can anybody tell me what is the name of this compound? What to write the name? This is
Nitro.
This is
Aniline.
called as para
Nitroaniline.
aniline. What is the name of this compound?
Orthonitroaniline.
Nitroaniline. Like this, you will get the para or orthonitroaniline. This is what is said to be the, see again I will explain you, nitration of aniline. In the nitration of aniline, the direct nitration of aniline will give, first of all, an anilinium ion, because it is a it acts as a base and accepts the proton and form anilinium ion, and the nitro group goes to the meta position, as anilinium ion is a meta directing group or ring deactivating. That's why to prepare orthonitroaniline or para-nitroaniline, then what we need? First of all, it should be deactivated. By treating with the acetic anhydride, you will get the compound is acetonylide. Acetonylide is formed, which on treating with the concentrated nitric acid and sulfuric acid, which is also called as nitration mixture, you will get orthonitroacetonylide and para-nitroacetonylide. Which on hydrolysis will get orthonitroaniline or para-nitroaniline. This is what is. Next, our topic is the oxidation. Oxidation. Are you getting this one? ఏమైనా వచ్చిందా మీకు ఇక్కడ ఒకటి?
Yes, sir. Oxidation.
Oxidation. Okay. Oxidation of amines. Let us see how does they undergo oxidation. Okay. First, let us take the oxidation of what you call it as the then see, I'll tell you this one. Okay, oxidation of amines. The oxidation of amines, what happens? See, the different compounds will give different products. For example, if you take what is said to be the primary amine, this is going to be the primary amine. When primary amine, when treated with the, okay, I will take one more to understood. We have to write one more thing is RCH2NH, so that we can understand this one. And here, this is going to be the a primary amine, and this primary amine, when treated with the potassium permanganate, it is a strong oxidizing agent, KMNO4. The potassium permanganate is a strong oxidizing agent. Whenever we treat with this oxidizing agent, first of all, you will get the compound is or CH. That is going to be, you will get the double bond here. Here you will get the double bond, and you will get another is the NH. That means what is lost here? One hydrogen from here, one hydrogen from here is lost, and it makes a double bond. And this compound is called as aldimine. This compound we call generally aldimine. Okay, aldimine. Aldimine. This compound we call it as the aldimine. Okay, now this on hydrolysis. Can you expect what may be the compound? This on hydrolysis in acidic medium, simply we will get aldehyde. You will get the aldehyde, or then it converted into the aldehyde. That means the primary amines always give what is the compound? Aldehydes. Suppose if it is a secondary amine, can you expect what may be the compound? Or CH, there will be one more R, isn't it? Secondary amines means there is two R's will be there, isn't it? And here or this is going to be the secondary amine. With the same reaction, can you expect what may be the compound? NH2. Okay. With the same reagent, what may be the compound you can expect? Here, see, here one instead of one hydrogen, there will be
RFS.
one R will be there. That's why you can write R, and here then see, here it is going to be the one bond here, and there will be double bond is here. There is no change. And here what to write? Here one or another alkyl group. Here also NH. Now what is the compound with the same with HOH and H plus ions? Now tell me what may be the compound by looking at the reaction. You tell me what may be the compound, and that compound is nothing but or. Very good, very good. That I need. Ketone will be formed. With the primary amines, we will get the aldehydes, whereas with the secondary amines, we will get the ketone. That is the important thing. Okay, you will get here the ketone. Okay, in this way, on oxidation, primary amines will give, sorry, this is oxygen. Primary amines will give aldehydes, and the secondary amines will give the ketone. This is going to be the secondary amine. This is secondary amine. Okay. Now, what about the tertiary amines? What about the tertiary amines? Tertiary amines undergo oxidation with either Carros acid. Carros acid is nothing but what we call it as the H2SO5. That is called Carros acid. This is the tertiary amines means here R, and here will be R, here will be R. O. No. Here I have to write nitrogen instead of this. N. And here this is going to be the tertiary amine. Or, and here another or. This is going to be the another. Sorry, this is also I told you something. Okay. Sorry, this is not a primary amine. I mistaken this one. Sorry. This is also primary amine. I'm sorry. And if the compound is, this is also because in ammonia, only one hydrogen is replaced. That's why it is also primary amine. And now let us go to the secondary amine. What is secondary amine? I'm sorry, because I'm mistaken. Secondary amine means like this, isn't it? N, here it will be N, and here it will be another alkyl group, is it? Isn't it? This is secondary amine. I'm sorry. And this is going to be the secondary amine. Now only one hydrogen is there for this. This is only one hydrogen is there here for this. And this is going to be the secondary amine. That is primary amines, depending on the condition, it may give aldehyde or ketone. But secondary amine, the secondary amine will give a compound called as tetraalkyl hydrazine. It is called as tetraalkyl hydrazine. That is nothing but here like this compound. There will be N, and here it is going to be one bond here, and there will be two nitrogens like this. There will be, there will be one more nitrogen here, and there is having here one bond, and for this also, here also. And this all are said to be the OR. This is also OR will be there. This compound is called as the this compound is called as what? Tetraalkyl hydrazine. This compound is called as tetra. Tetra means what? 4. Tetraalkyl hydrazine is formed. Okay. This is going to be the secondary amine. This is going to be the secondary amine. Sorry. Then what about the tertiary amine? Whatever the tertiary amine has no hydrogen. Therefore, it will have 3 alkyl groups. It will have the 3 alkyl groups. All these going to be the alkyl groups. OR, and here OR and OR. And this undergo, here also KMnO4, you remember? Here also it is, the reaction is at KMnO4. And here also, but here this undergo oxidation in presence of Carros acid, or Carros acid is nothing but H2SO5. Or another one is said to be the H2O2. What is the name of H2O2? What is the name of H2O2? Hydrogen peroxide. Either Carros acid or hydrogen peroxide. And this will give a compound called as N-nitroso-dialkyl amine. Simply, this is the going to compound that will be formed. N-nitroso-ammonium chloride. First, we will get, sorry, tertiary amines. R3NO, that is simply this here. I will take the same compound, C and V, and here the same. Simply there will be an oxygen will be there. Here an oxygen will be here. And you know that oxygen is always negative charge, isn't it? Oxygen will always be negative charge, and nitrogen will be this one. And this compound is called as the amine N oxide. This compound is called as amine N oxide. Amine N oxide. In this way, The tertiary amines undergo oxidation in presence of what is called carous acid or hydrogen peroxide, and you will get the compound is amine N oxide. Okay, the last, okay, before going to this, I want to take the attendance. Rachana is also there. Okay, now one more reaction, and I want to tell you this one more reaction is what happens when aniline undergoes oxidation. When aniline undergoes oxidation, this is going to be the aniline. This you know, there will be NH2. This is called as aniline. Okay. When aniline undergo oxidation, oxidation of aniline, and oxidation of aniline depends on the reagent that can be used. Okay, and I will make here at the center. Suppose if you use a compound like this and a reagent like this, potassium dichromate in presence of sulfuric acid, A2Cr2O7, okay, over sulfuric acid, H2SO4. Okay, when you use this reagent, and we will get a quinoline compound. What is quinoline? This is going to be the quinoline. See, we will get a double bond is here, and here one double bond, and there will be double bond here and here. And this compound we call it as the quinoline. This compound we call it as the quinoline. So the same oxidation when carried in presence of trifluoroacetic acid. When it is carried with the trifluoroacetic acid, CF3COOH. This is called trifluoroacetic acid. And when you use this trifluoroacetic acid, the compound we will get is the nitrobenzene. That is NH2 group become NO2 group. NH2 group become NO2 group. You will get a nitrobenzene. This is in this way, depending on the reagent that can be used, the aniline nitrobenzene. Aniline will give nitrobenzene, benzene. Okay. Aniline will give nitrobenzene with trifluoroacetic acid, but with the potassium dichromate, it will give, what is this compound? Quinoline. Quinoline. It will give the quinoline is the compound. This is the oxidation of what we call amines. Okay. 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 We will stop at this junction and we will discuss another one because only 2 minutes is there. Okay. I hope you understood what we discussed today: electrophilic substitution reactions and oxidation reactions of amines. Okay. I hope that you will understood. Okay. I think you understood. Shall I stop here?
Yes, sir.